right, we are on to our next module, and that is using an OS, or an operating system. So what do you think of when you think of an operating system? Okay, that's really what we want to kind of clarify in this module. So an operating system could be Windows, could be Mac OS, it could be Android, iOS, Chrome OS. That's the actual software that's installed on your computer that allows you to do different things. So that's what we're going to be digging into today, the different levels of kind of what an operating system is, a kernel, your drivers, stuff like that. So by the end of this module, you should be able to distinguish between the different types of operating systems that are out there and kind of have a feel for what they look like, but then also kind of the application behind them. Okay, so what operating system would you use for a web server, for example, if you want to host your own website? Okay, by the end of this module, you should be able to have a good understanding. Maybe you're not a subject matter expert on it, but you should at least have knowledge of the right one to use. Okay, we're also going to talk about some of the big players in this area. Okay, so I already mentioned Windows and Mac operating system, but we're also going to talk about Linux, Android, iOS, Chrome OS. We're going to have those discussions as well, and then we're going to finish up with just kind of how a web browser works, because, for example, Chrome OS is basically a web browser that's on top of the hardware, and that's how you kind of interact with everything. Okay, so that's what you can look forward to in this module. So what exactly does an operating system do? Okay, we talked about what an operating system is, and that it's a piece of software that allows us to install applications and stuff like that. But at the end of the day, what exactly is it responsible for? Well, first and foremost, it's the interface between your application, so let's say Microsoft Word, for example, and the actual hardware that is required to use that software. Okay, so if we look at our little diagram that we have over here, we have our different our software. So these are our user level applications. Okay, so this area right here, these are the user level applications. So in this case, we're talking about like Microsoft Word. Okay, from there we have our kernel. Okay, so the kernel is kind of like an air traffic controller. Okay, so you don't usually have just one software running on your computer, right? There's not usually just one application. So what the kernel does, it acts as this air traffic controller that says, whoa, Microsoft Word, I have Spotify over here that's using some, it needs to use the audio channel, or maybe it needs to use the CPU and the memory in order to process, and buffer some songs. So Word, you need to stop. Okay, come on in, Spotify. Okay, Spotify, you're done. Okay, go ahead and start Microsoft Word. It's what allows access to our different devices as a whole. Okay, so you can see down here we have our processor, our memory, our disks, devices, etc. And then also, in order to talk to these, they're going to talk to what's called a driver. Okay, so the driver is a piece of software that is the kind of the bond between our operating system and our actual hardware itself. So what exactly do I mean? Let's unpack that a little bit more. Okay, so device drivers are little pieces of software that says this is how this device works. Okay, so if we install a new printer, we have to install our printer driver in order for the operating system to know what language that it speaks in. Okay, so and that's what that driver has, is it has some software that says, hey, if you're going to send me a print driver, this is how it needs to be laid out, or this is the language that it needs to be in. Okay, so and we're going to get into this even more, but just so for this purpose of what we need to know so far is our software is at the highest level, and then it talks to the kernel, and then the kernel talks to the different hardware pieces by utilizing those drivers, so it knows kind of what how to speak to them. Okay, so an operating system as a whole, you probably have some experience with your phone operating system, whether that's Android, iOS, or maybe even your computer. Maybe it's a Windows machine or a Mac machine or Mac device. That sounds better. But there's also this idea of just like a black and white cursor just on a screen, and that's how you interact with that device. So a operating system doesn't necessarily have to have what's called a GUI, or a graphical user interface. It could just be our shell. And what a shell is, you type in commands and hit enter, and then it sends those commands through this process that we talked about over here. Okay, so, and I'll show some examples of a shell. You see this a lot on like Linux machines, where you just log in and you see that blinky cursor and you send your commands. Especially if you're getting into cybersecurity, a lot of the CTFs or capture the flags that you're going to do, you're just going to interact with them through through the shell of that. So what we talked about earlier, you're probably used to clicking icons and moving stuff around the screen. That's called a graphical user interface. Okay, so that's our GUI. You see this on Windows, Mac, Linux. All operating systems for the most part have some type of GUI that is installed. And then kind of a hybrid between these is the command line. Okay, so if you're on a Windows machine, you can go to the start button, type in CMD, and hit enter. And that'll bring up our command line. So we're in our graphical user interface, but then we can enter in commands from that interface. Okay, so let's say we wanted to check the IP address of our computer. The fastest way to do it is to go to our command line, type in ipconfig or ipconfig/all, and you'll see all of the IP information. Okay, so a lot of times the command line can help save you time, but also the command line allows you to build scripts, which is like a recipe where you can say, I want to do this, so I want to check the IP address, and then I want to put the IP address maybe into a variable and save it as a text document on the desktop, or something like that. Okay, that's where the command line kind of comes in, where you can be faster, and a lot of times you can't get this information in other places. You can only access it from the command line. Okay, so we talked a little bit about it earlier, but the kernel and our device drivers, the kernel is our air traffic controller. That's what I need you to remember for the test. The kernel is what is that in between our application at our high level and our device drivers at the lower level. So think air traffic controller. So when it comes to operating systems, you also have to take into consideration this idea of 32-bit versus 64-bit. So the biggest difference between the two is the amount of memory that you have access to. So you can see here on the 32-bit Windows, it only has access to 4 gigabytes, whereas if we have 64-bit Windows, we have 16 terabytes, okay? So even if you put 16 terabytes in your machine and you had a 32-bit operating system, you'd only be able to utilize 4 gigabytes of that, okay? So that's really the biggest thing. The second biggest thing is compatibility. So when you're installing applications, you have to make sure that the requirements of that software, let's say it needs to be 32-bit, which I hope not, that's probably an older software, but you have to make sure that it's installed on a 32-bit operating system for it to work how it was intended. Okay, so compatibility. You might have questions about compatibility on the test when it comes to 32-bit and 64-bit. Just looking at your requirements of the software and making sure. Also troubleshooting. You might get a question like, hey, this software isn't working, and you look at the machine and it's a 64-bit OS with a 32-bit software. Okay. Also, what an operating system does is it kind of keeps an eye on our health for us. So it makes sure that our hardware is running properly, or if it notices issues, maybe it's getting errors from the hard drive, it's going to alert you of those different errors that are there, okay? And then finally, data management. Data management is when you organize your files kind of into folders and then into, bigger folders and whatnot. Our operating system helps us kind of manage that data, okay? So when it comes to operating systems, we're still looking at this kind of high-level view. There's different types of operating systems based on what you want to accomplish. So what do I mean by that? So the operating system that's running on your phone is not really meant to be ran on a desktop. Now, there are some hacks out there that you can install, like Android on a Windows machine or a regular desktop or a Workstation PC, but that's not really what it's meant for, okay? So when you're doing a project, you have to make sure that the right operating system is installed on the machine for the use case, okay? So the first one being a Workstation operating system. The Workstation operating system is going to be our Microsoft Windows, our Linux, Chrome OS, and Apple OS. Okay, that's what's installed on our desktops or our laptop. Even though it's a Workstation OS, that can be a laptop as well. Okay, so this is more for our end user use. So if you're going to put a machine out there for a employee to use, that's going to be a workstation, whether it's a laptop or a desktop or an all-in-one. It's still going to use a Workstation operating system. Okay. So now in the corporate world, we have this idea of an enterprise client. So there are some benefits at larger, let's say you have a company and there's thousands of desktop machines. Well, they're not all going to work independently, okay? You need a way to manage all of those as a whole. So when I was a tech director at a school district, I was a one-man band. So I needed a way to manage across 5 buildings. I had hundreds of machines that were out there. So I installed some software that allowed me to do that, okay? That was a Mac OS, but on the Windows side, it's kind of built in. But you get different settings or different restrictions in order to make sure that that machine works as you want it to work, okay? And this could be, you might have seen things where like blocking the installation of apps, pushing out virus updates, pushing out Windows updates, all from a centralized place. When you're doing things like that, it's usually enrolled into a domain, which is where all of these computers kind of talk to one domain controller, and you're able to push out some of those settings. On the Mac side, you'll usually have some type of management software, whether that is like Jamf for Manage Engine, stuff like that. Absolute Manage, I think, is another one, where it'll pull those settings down and then make changes on that workstation operating system, okay? And then finally, the home client is probably what you have in front of you. If you have a computer in front of you, that's where you can go in, you can install, you're your own administrator at that point. You can install whatever software you want, you can install updates, you do all that on your own. It's not going up to a kind of a puppet master, if you will, okay? So then moving on to mobile devices, and mobile devices is like phones and tablets. Okay, those are the two things that we're talking about when we talk about mobile devices. Mobile devices, the big players are going to be Android and Apple iOS. Okay, those are the two big camps. There used to be Microsoft, there used to be Palm, there used to be other mobile operating systems, but the two big ones now are Apple, iOS, and Android, and those tend to be tied to the hardware, so you can't interchange them. I can't install Android on my iPhone and I can't install Android OS on the newest Samsung. Okay, that's just not how it works. It's tied to that actual hardware itself. And then finally, our server operating system. So really the biggest differences between a server operating system and a workstation operating system is that one polls and one serves. Okay, so think of it like a restaurant. When you order food at a restaurant, a server brings you that food. They're providing that service of that delivery and, getting you drinks and stuff like that. That's what a server operating system is going to do. So for example, a web server. A web server is going to host a website, and then from our workstation operating system, we are going to request that website from that server. So the server's standing there, it's like, hey, I have this website here, who wants it? And then our workstation operating system or even our mobile device operating system can reach out and pull that website down, okay? So again, at the core, there's not a lot of big differences. So like Ubuntu server versus Ubuntu desktop, the underlying kind of this lower level of operating system, it's really all about the applications that are on top that make that a server operating system, okay? So your big players in this area are Windows Server and Linux, and then you might see some Unix out there as well. Those are the three that you'll see on the test when it talks to you about server operating systems. And I urge you, so I'm working on the next podcast, and I urge you to download some of these things and set up your own lab environment, whether that's in VirtualBox, VMware, whatever that is, so you can really see how this stuff works. Here's a challenge for you. Download Ubuntu Server, install it into VirtualBox, create a website, and then access that website from your computer and your mobile phone. Okay, there's a little lab for you. And that's something that won't take you very long to do, and you can find plenty of guides on how to do that. And I'll link a guide how to install a web server on Ubuntu. I'll put that in the description as well. A lot of times too, that command line operation where we were talking about interacting via a shell, you're going to see that most with a server operating system, okay? Because there's two things. Number one, security through obscurity. So if someone happens to make it onto your server and they're kind of a lower level, they're going to be used to seeing and point and click stuff around. Whereas, there's a level of, like, for you to really mess something up, you have to have this level of understanding of the command line. Also overhead. you don't need this graphical user interface for a web server because everything can be done in the command line directly from that shell. Okay, so command line operating systems or shell operating systems you're mostly going to see on the Windows side, or I'm sorry, on the Linux side. And that's not to say Windows doesn't have that kind of headless mode, it's called, but you see it primarily on the Linux side. So open source versus commercial, okay? If you want to buy Windows, or if you want to get a copy of Windows, you have to purchase it. Same thing with Mac OS. Even though it's free now, they don't really have, on the Mac side, you don't really pay for that. But it is a paid or a closed source software. Okay, so commercial operating systems such as Windows, you have to purchase a license to use it. This is proprietary code, so it's all locked down at Microsoft. You have to, be on that team to kind of see that code. And then also the Mac side or the Apple side is also like this. Now on the other side of the fence is more open source operating systems, and this is where our Linux is going to come into play. And what's really cool about Linux is all of the code for the operating system is out there for the public because it's open source and everybody kind of comes together to make it better. So if there's a security issue, you have hundreds, if not thousands of people looking at this code in order to fix those issues, okay? And also what's nice about this is you don't necessarily have to pay for the software itself. Now, where these companies such as Red Hat or Conical, which is who manages Ubuntu, they do it by services. So they might offer a cloud platform that you can install it on, or let's say it's professional services. So you're setting up a new authentication server and you need help setting that up. They'll sell those professional services in order to help you do that. But the actual software itself, they don't actually charge for. Okay, so some of the big open source versions are Unix, Linux, and Android, but then like Linux, for example, has like a whole family of operating systems that are out there, like Fedora, CentOS, Slack, Ubuntu, Kali Linux. Those are all ones that they're different flavors of that, or they're different versions made for specific things. Remember earlier we talked about making sure the operating system fits the use case. That's where those different versions of Linux are really going to come in. Now the next one is the embedded OS. So an embedded OS is going to be like this camera that I'm using is a Sony camera. In it, it actually has an embedded operating system that is specifically made for this. Okay, so it has things that it can change. Same idea in that there's an operating system, there's applications, and then it talks to a kernel, which talks to the hardware. It's that kind of same idea, like a Fire Stick. That's going to have an embedded operating system. What else? Oh, like the Google Home things where there's a screen. Those have an operating system on there, but they're a very simple purpose. Okay, they're made for that specific device, and a lot of times those tend to be closed source. You'll see this also with like HVAC controls and stuff like that. They're going to have their own embedded OS, and they're really good at one thing. It's not meant to be a general use thing where you can go in there and install applications and stuff. It is specific for one thing. And if there are applications, they're specific applications from the actual manufacturer itself, okay? A lot of times these are they're made for high uptime. So mission critical would be another word that I would use for embedded operating systems. They're available at all times, so we can't have the power grid going down. So that's why these embedded operating systems, they get rid of all the junk that they don't need to have solitaire on there, right? You don't need to have any games on there. It has a very specific use case, and that's what our embedded operating systems are going to have. So similar to an embedded operating system is firmware. So firmware is a very, very small piece of code that is installed on the device at the almost like the hardware level. And what this does, it allows for any security flaws, so like jailbreaking, for example, or rooting your phone. They might push out a firmware update that blocks that from happening, okay? So firmware updates can also add some functionality. So that's why like your Xbox, your PlayStation, your Switch, your gaming consoles, your actual devices, they have a little piece of software on them that is their firmware, and There's not a lot of updates that come out a lot for firmware, and unless it's like really new and they're still fixing some bugs. But this is actually installed on the actual hardware itself. It's a piece of software that's running on the hardware. The biggest version of this would be like our laptops or our desktops, and that comes in the form of BIOS, or Basic Input Output System, or UEFI, which is the Unified Extensible Firmware Interface. So this allows us, before we even boot into our operating system, to go in there and make changes or check on the health, stuff like that. It's an operating system before the operating system, okay? Which sounds confusing, but bear with me. So if you boot up your machine, you'll have, if you look really fast, you'll see where you can enter the BIOS. And when you go into the BIOS, you're going to have access to things like, what do you want to boot first? Do you want your flash drive to boot, your CD-ROM drive, your hard drive? It's those types of settings that you're going to see on this operating system. BIOS is what we've had for a long time. That's an older technology. It tends to be just keyboard and just like a blue and white type of screen. With UEFI, we've actually gotten mouse support. It's more graphical. There's like fancy graphs now when it comes to like gaming PCs and stuff like that. And it gives us a few more features. Okay, so we can go in and do some overclocking. We can go in there and work on like the security features of it, like TPM chips and secure boot and stuff like that, which is outside of this course. But just think of it having, if you think like the oldest operating system that you can remember, maybe you think back to like Windows XP, and just see how much we've changed into Windows 11, or the first iPhone or first gaming system that you had compared to where we're at now. That's the difference between BIOS and UEFI. Okay, so we've gotten a lot more features. We're able to use our mice. It's a lot more user-friendly on UEFI than BIOS was. Also, from time to time, you might have a firmware update that comes through Windows updates for things like our video cards and our other peripherals that are installed. Okay. So now we're getting into one of my favorite topics, and that is virtualization. So virtualization is the idea that where it came from is we used to have servers that were in racks, and their actual workload was only about 30 to 40%, and maybe it was just the print server. Okay, so we had an overhead of about 60% that just wasn't being used. So that's where virtualization comes in. Virtualization allows us to install more than one operating system on a physical device, and it allows us to then have our physical server, and we're running two operating systems on top of it. Okay, I urge you, please download, whether it's Hyper-V, VMware, VirtualBox, any of those virtualization software. They're free. Download them and start playing. Okay, that's where you really learn, is when you start playing with this stuff. Okay, and you don't really necessarily have to have a super strong computer to do this, but you are assigning your hardware resources when you build the virtual machine. So you can see here on the screenshot that, let me delete that last drawing, that on this machine, we're giving it 2 gigs of RAM, 1 virtual processor, and a certain amount of hard drive space. Okay, so let's say our machine only has 4 gigabytes. That means Windows that's running will only have 2, because we're giving our virtual machine 2. So now if we create a second virtual machine and give it 2, we're out of RAM, because that equals 6. 2 plus 2 plus 2 equals 6. So you just have to be cognizant of the actual resources that you are giving to your virtual machines. And I'm going to be doing a video that just talks about like kind of stepping through VirtualBox and creating your first VM. So stay tuned on the channel for that. But for the actual test itself, what you need to realize is there's a couple different versions of virtualization. Okay. So we have our host machine that's running. Okay, so let's go ahead and draw our host machine right here. Okay, so this is our host. So the first one that we have here is a type 1. Okay, that is bare metal. So that means our host is also, kind of think of it as our hardware. Okay, so that's our CPU, our memory, our hard drive, our motherboard. That's what this host is. So with a bare metal or a type 1 hypervisor, we are going to install the software directly on here. Okay, so this is going to be ESXi is a big one, ESXi by VMware. There is a version of Hyper-V, unless they discontinued it. And another one is something called Proxmox, which I've used. The ones that I've probably used the most bare metal are ESXi and Proxmox. So this software is installed on the actual host, and it's very, very small. There's not a lot of bells and whistles, if you will, and actually you access them via a web browser. Okay, so to make that footprint even smaller, where it doesn't have to have that big graphical user interface, you actually access everything via a web browser. And then on top of this, we have our different VMs. Okay, so we have VM1, 2, and 3. Okay, so these virtual machines then are going to be running. We could have this one be Windows, this one be Linux, and maybe this one's going to be Unix. Okay, so the biggest difference between them two, and how I like to remember them, is how many hops is it between your VM and your hardware. Okay, so if it's directly installed, it is only one, whereas with Type 2, which we're going to get in a minute, it's going to take 2 hops to get there. Okay, so a bare metal hypervisor, the software is installed on the machine itself, and then the VMs are sitting right on top. Okay, so let's go ahead and clear that out. We'll get our hardware back here. So the next one is a Type 2 hypervisor, and this is what you are probably going to use for your own home labbing when you only have like one machine. Now you might graduate and have a dedicated VM, a virtual server at some point as you develop your home lab. But starting off a Type 2 hypervisor, we're going to have our host, and then we're going to have our operating system. So we'll say it's Windows. Okay. And then on top of that, we'll have our different VMs. So notice now there are 2 hops to get to our actual hardware. Okay, and it can still be Linux, it still could be Unix, and it could still be another Windows machine, but we install Windows first and then put those on here. So what exactly is the use case for a Type 1 versus a Type 2? Well, Type 1 is going to be used in our data center or in our network closet to host all of our different servers, okay? Whereas Type 2 is made for more of a testing, or maybe you want to do some capture the flag, some cybersecurity stuff. Maybe you want to test out a new operating system. That's where our Type 2 comes in, okay? So in my classroom, I have 5 VM servers, and those are for us to use in the classroom. Whereas on my laptop, I have a laptop, a Dell XPS, that has, like, I think 64 gigs of RAM, and that's where I install different operating systems that I want to play with, or different servers and stuff that I can practice with, maybe download some vulnerable machines to try to hack into them. Okay, so that's what that Type 2 is mostly going to be used for. The actual machines that are installed on your hypervisor, those are going to either be called the guest operating system or virtual machines, okay? Because they're a guest on the actual hardware itself, okay? So we have Windows, and then we have this guest that we've invited in. Hello, Ubuntu, come on into our party. You can now live here, okay? Until I need the resources, then I have to kick you out. But you are a guest here now, okay? So biggest takeaway for virtualization: saves money and resources because you don't have underutilized hardware. Manageability also, I can just take a snapshot of a virtual machine before I install an update or some software, and if it messes up, I can just roll back to that snapshot. It's easier to back up, so I can just easily take that machine and back up those files to another one. Or in the case of a natural disaster, like we had tornadoes come through this area not too long ago, let's say a data center was right in the path of a tornado, I can actually do a live migration of that server to a whole nother data center should something happen. Okay, so disaster recovery is a lot better when it comes to virtualizing as well. But again, those are going to be our bare metal hypervisors that have those kind of higher availability features. So let's start breaking down the different versions of operating systems that are out there, starting off with Windows. We're starting off with Windows because that's the heavy hitter. About 90% of the machines that are out there are running Windows. Now, over time, as we've been using more and more mobile devices, iPads, phones, stuff like that. We're seeing that number go down a little bit, and Mac is also getting some market share as well. And there's constantly going to be that back and forth. But it's the big player, especially in the corporate environments. It's just a lot easier to manage a Windows machine because that's how it was developed from the very beginning. Also, compatibility. You might have large corporations that have a big investment in a certain software, and they need that backwards compatibility, and Microsoft Windows has really, really good backwards compatibility. There are both client and server editions, like we talked about earlier, and there has been many different versions over the years. So for the test, they're going to be primarily talking about Windows 10, first released in 2015, and then there were these, they used to be called service packs, now they are anniversary updates. So these are different feature packs that come out that add more functionality and also like bug fixes and stuff like that. So I like to call them service packs, but they are just big chunks of updates that get pushed out. But yeah, it came out in 2015. Microsoft Windows 11 came out like what? 2021 maybe in that time frame. So you can see that this one was on the shelf for a long time. It's a pretty common operating system. It's a good operating system. It works on both desktop computers and laptops, but also on some tablets as well. Microsoft has their Surface line of products that are tablets. So there's a lot of features that are built in that are just directly built into the operating system for it to run well on those tablets. Okay. Some older versions that are out there, Windows 8, which was rough because they tried to eliminate the start button, and they tried to do this like Metro UI thing, and it just, in the business world, you have people that aren't computer savvy, and then what they log into every day is now changed. So they ended up changing that back. They put the first version of Windows 8 did not have a start button, but in version 8.1 it did. So after Windows 8, we went to Windows 10 and now Windows 11. There for a while, it was like every other operating system that Microsoft put out. You'd have like Windows XP, tried and true, huge. But then Windows Vista came out, and people are like, oh my God, don't like it, hate it, different, people don't like change. And there was just a lot of bugs in Windows Vista. But then Windows 7 came out, boom, tried and true, worked well, kind of resembled Windows XP a little bit more than Vista did, and it was used, at the time of this test, 43% of the market share. It has now since been end-of-lifed. Then we went to Windows 8, which freaked people out with no start button. Now we have Windows 10 and Windows 11, which we're seeing much faster additions that are much faster. Kind of moving to Windows 11, people are comfortable with it, especially in the enterprise. So Windows comes in a couple different versions. So the biggest ones that I want to call out are the idea of this home version versus this pro. And enterprise and education, they kind of fall under this pro as well. The biggest difference is, number one, right tool for the right job. So making sure that you're not running Windows Home and then you're expecting to use it in a more corporate or office environment if you want to take advantage of some of those management features that we talked about earlier. In order to have your domain controller or centralized authentication, centralized print services, those kind of things, to be able to add like group policy to manage that device, you're going to need to have at least Pro if it's a small business, or Enterprise if it's a much larger business, okay? So I keep talking about group policy and this idea of a domain controller. So in a Windows environment, we're talking about like a corporate environment, you have what's called a domain controller. So the domain controller, and then we have our client PCs out here, okay? They talk back and forth between this domain controller to pull things like settings. So let's say, what printer should I print to? I'm on the second floor of this building. Which one should I print to? You don't want to have it install all the printers in the building, especially if it's a large corporate complex. Like, that's just going to be overwhelming for that user. So just giving the user exactly what they need. Also blocking things like software install. Again, we're just managing our client itself. That's what the domain controller is going to help us do. And it's going to help us by doing that by centralizing our authentication, okay? So let's say a new user shows up, you don't have to go to 1,000 machines and go create a user account on all those machines in more of a corporate environment. You just add them in one place. We add them to our Active Directory, which is in our domain controller. And then when they log in, this computer is going to reach out and say, hey, can this person get on this machine? It's going to go back and say yes, and here are their settings that they need to have, and then it'll go through initial configuration, and then it's good to go. It knows that that user is assigned to this department, so it'll give them access to like file shares and stuff like that, what printer they're supposed to be hooked up to, all of that fun stuff is going to be through this kind of centralized location. Okay, so hopefully you see the advantage of that instead of going to every single end user machine and trying to make those changes. You do have to realize too, Windows comes in both 32 and 64-bit, but most of the time you're going to be using Windows 64-bit. So Mac OS, we already talked about, it is kind of locked to the hardware in that the Mac operating system can only run on Mac hardware legally. There are some Hackintosh things out there, but honestly, they're buggy and it just doesn't work really well. It's designed, and one thing that's really cool about Mac compared to Windows is Windows does software. You know, they do have their hardware line where they have the Surface line of products, but for the most part, they're focused on that operating system. Whereas Apple has to worry about Apple. They don't have to worry about Dell. They don't have to worry about, you know, HP, Acer, Asus, all these different hardware brands that are going to put different components inside. They have full control over that entire process. So they know what CPU's in there, so they can optimize their operating system for that CPU. And they're even recently taking a step further and designing their own CPU so they have even more control, so they can provide a better user interface or a better user experience to that end user. So for the most part, it is Mac OS is what it's called today. Back in the day, they used to have, so we had Mac OS 10, which was back in 2001 is where it started. And they used to have these different cat names, okay? So we had cheetah, puma, jaguar, panther, tiger, leopard, snow leopard, lion, mountain lion. And then we saw this change in 10.9 where they started changing to, instead of cat, they kind of ran out of cats, if you will. So they went to different large like landscapes, and different mountaintops and mountain points and stuff like that. So we have Mavericks, Yosemite, El Capitan, Sierra, High Sierra, Mojave, Catalina, and Big Sur. And then we've had some since then as well. So when you're looking at Mac OS, really for the test, you just need to know that it is Mac OS and it is Mac OS 10, and now we're getting into Mac OS 11. It used to be, a question might be, what operating system used to have cat names? So just know that that's kind of weird. Cats like apples, maybe? They like to eat apples. Cats eat apples? I don't know. Just kind of think about just something that'll help you remember that. I doubt that you're going to have to know all of these. Like, you're not going to have to know that in 2007, Mac OS 10.5 was leopard. And then in 2009, we got snow leopard, and it was just speed increases and security increase. Like, you're not going to have to know that level for this exam. So moving on to our mobile devices, we have our Apple iOS, and this is what you probably have some familiarity with if you've ever used an iPhone. It only runs on the iPhone and iPad, okay? And we're seeing that really cross over where now you can build an application and it'll just work for both. Back in the day when I did some iOS development, you had to design it for both independently. Now, the software has just gotten a lot more advanced, and it'll allow you to have kind of that one code base for both. In this version, you can see I put a note here, in this version of the operating system, and it's 11 and 12, we're obviously a little bit further beyond that. And the version updates come through, whenever new versions come out, it does sometimes, they lose. So for example, like I have an iPhone SE here. So it's only going to be able to upgrade to a certain level of that iOS. I saw this a lot in iPads in my day, where those first original iPads, the software came out, the version of the software of the operating system became too advanced for the hardware, and then you couldn't install any applications, and they kind of became dead in the water, which was really unfortunate because the devices still worked, but we just couldn't put any applications on them. So that is something that you see. Like I talked about earlier, Windows does a really good job with backwards compatibility. Apple tries to stay cutting edge. And I'm not saying like you're going to buy a device now and you're not going to be able to use it in 3 years. Okay, that's not the case. But when you're getting out to that 5 and 7 year mark, when it comes to mobile devices, definitely. So now let's break it in, jump into Unix, Linux, and Chrome OS. They've kind of lumped all of these together as our kind of our open source, if you will. So Unix is developed in parallel by various different institutions that are out there. Mac OS, fun fact, is kind of based in that Unix area. So if you go to the command line, a lot of your Unix commands are going to work on the Mac OS. Linux is kind of our biggest player when it comes to open source. It was derived from Unix. It kind of split off, if you will, but it's fully open source, meaning everybody can see it, everybody can work on it. You can pull down and build your own kernel if you want and build from the ground up. You can build your own operating system. There's multiple different distros that are out there, and think of that as like different versions. Distro is short for distribution, but you'll see here we have SUSE, Red Hat, Fedora, Ubuntu, Debian, Mint, there's Pop! OS, there's a bunch of them. So if you really like that Mac environment, you can actually download a version of Linux that looks like the Mac environment. You see this mostly on the server side, but there are some client use cases out there, and the manufacturers like Dell and HP, I think, were the two big ones that had driver support right out of the box. And that's what you're going to run into on the Linux side is kind of driver compatibility. So new hardware comes out, and who is the hardware manufacturer really care about the most? It's probably that 90% market share of Windows, right? Because that's where they're going to be used the most. So it kind of relies on the community in order to develop drivers for it to work on open source platforms like Ubuntu and stuff like that. So mileage definitely may vary when it comes to Linux and installing it on like home PCs. But on the server side, you tend to have a lot of support because Linux is used primarily in that server space. Chrome OS, we talked about this a little bit earlier. It's basically just a web browser that you access everything through. So at the school district that I work at, all the students get a Chromebook, and it uses kind of that centralized login server is actually Google at that point, and we can make changes in our dashboard, and those changes happen on the end user devices. So they work really well with web applications, but as far as like installing anything, they don't really install, they just run web applications. So it's just like a machine that just has a web browser on it, okay? And these do come in desktop and laptop versions, but primarily you're gonna see it as laptop versions. So jumping into a couple of the different Linux versions, if you want to try pull this graphic down, beginner friendly, you're going to see Ubuntu is probably the most supported. You're going to see the most, articles, Reddit articles, YouTube videos on Ubuntu. Pop! OS, I played out with that a little bit. It's just a different kind of front end for Ubuntu. Same thing with elementary. A lot of these are based on Ubuntu. Intermediate, we're going to see like Fedora and OpenSUSE. Those are going to be a little bit a steeper learning curve. And then hard mode, we can see here Arch, Slackware, Cubes OS. Those are going to be the ones that you basically develop everything from the ground up and pretty much build your own operating system. Even at my level, like I have Linux certifications, I'm pretty comfortable in Linux. I have Linux servers set up. I really don't usually play in this mode. I'm usually at an intermediate to beginner unless there's something very specific that I need to set up. Android is also a Linux-based operating system in that it is derived from Linux. It allows these different vendors to customize the kind of interface and how the device is used because it is open source, so they can kind of develop their own software and put it on top, whereas there wasn't really like other options that were out there. Gosh, I want to say at Best Buy when like the first Android devices came out, and at that time we had Palm, BlackBerry, Windows. Apple had just come out with their operating system, but those were the big players, and they didn't really give a lot of customization. So if Acer wanted to build their own mobile device, they had to kind of create their own operating system, where now with Android, Google came out and kind of built this mobile operating system, and all of these vendors were now able to focus on what they're good at, which is making hardware, and then have kind of that version of Android on top, okay? So these are the different versions of Android over the years. They were all desserts before, so just remember that Androids like to eat desserts, where cats like to eat apples, I guess, if that's a way for you to remember it. I don't know. But they used to be all based on desserts, and then it switched with Android 10 and Android 11. They've now just kind of gone to the actual names, kind of followed suit with like Microsoft and Mac OS to have just regular versions of the operating system itself. And to my knowledge, I think we're on Android version 11 right now. So one of the things that we talked about on the operating system slide was that it's responsible for file management. Okay, so here's an example of our different files and folders and locations that we have on a Windows machine. So at our root, we have our different hard drives that are out there. So in this case, we have our C drive, which is where our operating system lives. We have this external drive plugged in, and then we also have our flash drive plugged in. So what you can do is you can actually double click on this device and it'll take you to our different folders, and we can put our files within our folders. Okay, so our folders go on the drive, and then from there we can put files inside of them. I'm not saying that you have to, you could just dump a bunch of files on a drive, but you want to do your best to keep everything organized so that way you're able to find it when you need it. Okay, so on the couple things to point out here on the kind of File Explorer or Windows Explorer is if you click on this PC, that's what's going to give you access to all the drives that are in there, as well as some common folders that are used. So our desktop, our documents folder, our downloads, our music, pictures, videos, those are kind of quick access things for us to get to. So from there we can drill down into different folders and things like that. So under pictures, maybe we have a family reunion folder, and in there we have the 2018, 19, 20, 21, 22, all these different folders within that have all the photos from that family reunion, let's say. Okay, so chances are if you've used Windows, you've kind of had interface with this when it comes to like saving your files and stuff like that. But the most common one that you need access to is this PC, and then also this idea of a network. So if you're on the domain, like we talked a little bit earlier in that corporate environment, chances are you have shares that you share with other people in your department. So the marketing department might have a share that has different assets. So it might be logos, they might have access to some software on there, different files, templates, stuff like that. So they would access that through the network because they're all coming together in order to work on that. That has also kind of changed in that with the kind of hybrid work area or work from home hybrid environments that we have, a lot of those have moved to something like a cloud-based software. But there is still a lot of corporate places that have these shares that are saved on the actual network itself. So looking around the operating system a little bit more, we have access to our settings, and you can access this by hitting the start button or the Windows key and typing in settings. And from here we can go in there and we can change our network settings. We can create a new account. So let's say, someone's staying with you or you need to let someone borrow your computer, you can go into accounts and create that actual account. And we're going to go into more of the specifics here, but just as far as like your top level knowledge, just know that Windows settings is similar to Control Panel in that Windows settings is kind of our new version of the Control Panel. They're trying to simplify things for end users, but this is where you can go in there and make system-wide or operating system changes. Okay. Same thing with Control Panel. This is kind of our older version. There's still some things that I've found it's just quicker and easier to go through Control Panel to do. With the new version of Windows 11, they're kind of migrating more of that stuff into settings, but Control Panel is still there. It's also worth noting that you can change the view, so if you can't find what you're looking for, first just try to search Control Panel, but if you can't find it, you can also change and just change this to like a list view if need be. So another thing that you might have to get into for your clients, so like for a school district, for example, I have students that have different needs, so they might need like a screen magnifier. Maybe they don't have the best vision. So the best and easiest way to do this is just hit the Windows key and just start typing ease of access, and it'll actually take you to this section where you can set up, if you need to set up the magnifier like I talked about, if they need an on-screen keyboard. And it might not necessarily have to do with a disability. For an on-screen keyboard, it might be a machine that's in like a cafeteria, for example, and they need to be able to just touch stuff. They don't have a regular keyboard, so that's where you might have to turn on that on-screen keyboard for them to use, okay? So if you're looking for more advanced tools or quick access to some of these more advanced tools, if you hit the Start key in X or right-click on the Start button, it'll bring up this different kind of hidden menu, if you will. So from here, we have access directly to our device manager. Okay, so device manager will show you all the hardware that's on your machine, and you can do like device updates and stuff like that. Or if something's not working, piece of hardware is not working, you can go into device manager and check the status of it. We get access to Windows PowerShell, which is like control panel on steroids. There's a lot of other features that are built in. Event viewer, so maybe there's some errors on the machine and you want to see kind of if there was any, if the operating system logged any of those errors, if you wanted to get a little bit more into those. If you want access to your disk, maybe you're running out of storage, or maybe you put a new hard drive in and you want to format that drive, you can do that through disk management. So all of these are available by hitting the Start key in X or right-clicking on the Start button. Also, all of these do have commands that you can type in. So if you hit the Windows key plus R for device management, for example, you can type in dev mgmt.msc and it'll bring you directly there. But those are things that you learn over time. You learn some of these time-saving little hacks that will make you more efficient. But just starting out, the fact that you actually know how to get to this menu now is pretty cool. Like, I didn't, even as a power user, I didn't know that really was there until I accidentally hit it one day and I was like, oh, this is easy to get to. I can instantly go right to computer management and see what's going on. So again, I urge you to kind of play with this stuff and open each and every one of these so you get familiarity of what it does, okay? So we're getting kind of to the end of this module, talking about using a web browser. So the big players in the web browser market are Google Chrome is huge, Mozilla Firefox, huge, Microsoft Edge, because it's installed in 90% of the computers out there, so Edge, being the web browser that's part of Windows, is pretty popular. And then on the Apple side, you have Safari, okay? All of these now are very similar. My personal web browser of choice is Edge. I think it does a little bit better with like memory management and stuff like that. But again, try them all. See which one works for you. You can even get Safari. Last time I checked, you can even get that on Windows. But what's really cool about these web browsers is they do sync between your mobile devices and your tablets and stuff like that. So if you save like your login, you'll be able to log in on your phone because you have the web browsers are what's in sync. They sync kind of with your account, which is really cool. What you have to know as far as the actual exam itself, number one, this is our address bar. So in the address bar, you have a URL. So that is our Uniform Resource Locator. So when this www or this web address that's up here, that's going to be our URL that we go to. Also, this idea of tabbed browsing. I remember when this first came out. So all of before you used to have a bunch of windows all over the place, and you'd have to move them around. Firefox, I want to say, was one of the first that came out with tabbed browsing, and now it's just kind of the norm where you can open these different tabs behind here. By hitting Control-T, it'll open up a new tab, and then you can quickly jump back and forth. So right now, I'm presenting from Google presentations or Google Slides, and I can, this is literally in a tab, I've just full screened it, okay? So I have a bunch of other tabs that are running that I can bounce back and forth between them, okay? And then this is our actual website itself. So number one is our address bar, number two, we're talking about tabbed browsing, and number three is the actual website itself. So I referenced this a little bit earlier, our URL, or our Uniform Resource Locator. You'll need to know that for the test. It is made of a couple different things, okay? So this first part here tells us what protocol we are going to use, okay? And this is a little bit more advanced. We're going to get into it. But for what you need to know right now, HTTP equals a website, okay? HTTP and HTTPS are going to be if we're accessing a website. So then the second part tells us what is the actual place that we're going to go. What is the location? okay? So in this case, it's store.comptia.org. So once we get there, what folder are we going to go into? Okay, so this is giving us directions, okay? So what is our mode of transportation? Okay, so we're taking a car. Okay, we're going to a mall. Okay, so that's what we're doing. How are we going to get there? We're going to take a car. And then what is the name of the mall that we're going to? We'll say the Midway Mall. Okay, Midway Mall. And then from there, what store are we going to in order to get our, whatever it is. So we're going to go get some shoes. Okay, so we're going to go to the shoe store. Okay, so these are the three very distinct parts of a URL. It tells the web browser the what method are we using to get there, where are we going, and then in what folder do you want to browse to. Okay, having a firm understanding about kind of how this URL works is really going to help you when it comes to cybersecurity, okay? Because we're going to do things like maybe we are attacking this machine, okay? So this is the machine that we are attacking. So we might do something like Dirbuster, for example. Dirbuster is going to go through and randomize this section to try to discover some of those folders that are on there, and then from there we can find different applications that we can use to attack in those folders. Okay, but that's, again, if you're going that cybersecurity route, you really need to understand this. You need to just take note of, like, when you go to websites and stuff, and just start recognizing, like, we're in the ITF section, and then it goes to the index.htm that's in there, because there could be another one that is, let's say, the A+, okay, and it's going to have its own index.html that's in this folder as well. Okay, so these have the same names, but they're in different folders, so they're going to be two totally different files. Okay, so just even from a troubleshooting standpoint, you need to understand the different parts of the URL, so that way you can figure out kind of why things aren't working for users. Okay, does that make sense? Hopefully it does. So then our browser controls, again, if you navigated to this video, chances are you probably know about these different back and forward, stop, refresh. These are all kind of common controls that you feel like you're almost born with them. And then the only other thing would just be, again, keeping track of this and understanding this address bar and kind of where this is going. Okay, so just make sure that you have a good understanding of that. So hopefully by the end of this module, you can now distinguish between different types of operating systems designed for workstations, servers, mobiles, how about mobile devices, embedded systems, and virtualization, and then identify the different use cases for those. I think we discussed quite a few in this module, so hopefully that'll kind of get your brain turning for kind of the differences between them. So let's look at a few review questions, okay? I'm going to go ahead and let you pause it right here, and then when you resume, I'm going to go to the actual answers on screen as well. Welcome back. Here are the answers. So hopefully you did well on that. And if not, feel free to reach out. Watch the video again. If you need more resources, if you need a little bit more understanding, please reach out. That's what I'm here for. I'm here to help you guys. My success is based on your success. So if there's absolutely anything I can do for you, please let me know. That's all for now. I will see you in the next module.